All right, moving on to number 5. First off, there's a typo I told you guys to fix in class. If you didn't fix it in class, go ahead and do it now. That should have been a square root 28 right there. So square root 28 plus 3 square root 7. Okay, now starting the problem from there. This 7 is prime, so we can't do anything with it. This 28 right here can be reduced. And remember, we can't add two radicals until they have the exact same radicand. So this 28 and this 7, they're not going to mix together like oil and water. Well, we can reduce this 28. So let's do the exact same steps we've all done before. 28 is going to be 4 times 7. So that's square root of 4 times 7. And then I'm going to let this 3 root 7 just copy down and go for the ride. The 4 comes out as a 2. Square root of 4 is 2. So 2 root 7 plus 3 root 7. Now that I have the exact same radicand on both, well, now I can go ahead and add those two coefficients. So 2 root 7 plus 3 root 7 is 5 root 7. And that is the answer. Now, don't let that fool you, because what ends up happening is a lot of my students want to try to combine the 7 and the 7 to make a 14. But, I mean, just treat those things like it's one solid unit. I mean, remember back in, elementary school, 3rd, 2nd grade, somewhere in there, where you started doing this stuff? 2 boxes plus 3 boxes equals 5 boxes. And then you eventually got to where you could do bigger and better algebra. So we put x's there, and now we're putting square roots there. Just remember, if you have a coefficient in front of a variable of some kind, you never ever change what's inside that variable. You just add the two coefficients.